Hi, grade 6. This is a math video for chapter 8, form 2B. I'm going to do problems similar to the ones you're going to see on form 2B, but I'm not going to do the ones on form 2B. So let's take a look at 1, 2, and 3. How would I estimate those problems? How would I estimate them? Let's start with number 1. What if I had a problem like, say, 39% of, say, I don't know, how about 349? Well, first I'd change this to 40%, and then I'd change that to multiplication. I'd change this to 350, and I'd say to myself, hey, what fraction is this? This is really 40 hundredths, which is 4 tenths, which is 2 fifths. And is there any way that I can do this problem? 2 fifths times 350 over 1, sure. Let's do some cross simplifying. Divide by 5, you get 1. Divide by 5, you get 70. Final answer is 140. Done. How about the next one? I'm going to do one similar to this. 0.5% of 600, but I'm not going to do the one for 600. I'm going to change it to 400. Okay. First thing I realize is that this is smaller than 1%. So I'm going to figure out what 1% of 400 is, and of is multiplication. So I write 1% times 400. Then I realize, wait a minute, 1%, that's 1/100th. So what's this equal? Isn't that really 400 over 100, or just plain the number 4? Now, this percent, 0.5%, I would have to multiply it by 2 to get to 1%, right? So, in other words, it's half of the 1%. It's half of the 1%. So, if I can figure out what half this number is, what's half of this number, I got my answer up here. And in this case, half of 4 is 2, isn't it? So that's similar to problem 2. Problem 3. Problem 3. How would I do something like 194% of 17? Well, I'm not going to do this problem, but I will do this problem. What if instead of 17, I change this to, say, 38? Okay? I'm going to think about this as being similar to 40, and I'm going to think about this as multiplication. I'm going to think about this as being similar to 200%. Doesn't percent means hundredths? Yeah. Why don't I just do that problem? These two numbers can both be divided by 10. If I divide by 10, I get 4 and 10. And then, I can just multiply, and I get 800 over 10, which is 80, isn't it? Because 800 divided by 10 is 80. So you can do number 3 similar to that. Number 5. How would I do number 5? Well, I'm not going to do number 5. Number 5 says find 18% of 54. Find 18% of 54. I'm not going to do that. What if it said, say, find 21% of 60? Find 21% of 60. Well, all I do is take 0.21 times 60, because that's all they're asking me to do. And in this case, the answer would end up being 12.6, I think, when I do the math, 12.6. How about the next one? They say find 48% of, it says 48% of what number is 35. This one's slightly different. Of is multiplication, so I'm going to think 0.48 times n equals 35. And I got to solve for n, don't I? But I don't want to do this problem because that's your problem. I'm going to change this 35 to 70. Okay? How would I do that? Well, I would end up dividing both sides of the equation by 0.48 because I want to get n by itself, right? So what in the world is 70 divided by 0.48? It's somewhere around 150, I think. Nope, 145.83. 145.83 repeating would be the answer in this particular problem. So yours is similar to that. but not exactly like that. Feel free to pause at any time if you want to think through the problem that you've got. I'm on number 6 right now, which says 127 is what percent of 50. But again, I'm not going to do this problem. I'm going to do 127 is what percent of 60. Similar problem, just not exactly the same. That is my equal sign. I'm going to write this as n%. My of is multiplication, and my 60 stays 60. Now, how am I going to get n by itself? Aren't I going to have to divide both sides of the equation by 60? You betcha. Divide both sides by 60. We get n% equaling whatever that is. 127 divided by 60 equals 2.116 repeating, I think. Yep, 6 repeating. Now, look at here. We still don't have a percent value, do we? We got a decimal value. And remember we said n% really means n over 100. So I got to take this, and I've got to multiply both sides by 100. And when I multiply both sides by 100, I get 211.6 repeating. And now I can call it percent. 127 is 211.6 repeating percent of that 60. Okay. How about number 7? Predict how many registered voters would vote for Jones. Well, if you look at the chart over there, Jones has 23%, doesn't he? Now, I'm not going to do the one for Jones. I'm going to do it for somebody else. But we also need to notice that in the directions above 7, it says that there's 50,000 registered voters and 574 of them were surveyed. Okay. So I'm going to do it for Alvarez, but you need to, no, I can't do it for Alvarez because Alvarez is problem 8. Okay, I'm going to do it for Mulrooney. Okay, so if Mulrooney got 33% of the vote, I'm going to create a proportion that looks like this. I'm going to put my 33% on the right-hand side for Mulrooney, and I'm going to take my 50,000 people that are voting, and I'm going to write it right down here, and I'm going to solve for x. So basically we're saying if Mulrooney got 33 out of every 100 votes, how many votes out of 50,000 would Mulrooney get? And so I'd have to take the 33 times the 50,000, and I'd have to divide that by 100. And when I do that, Mulrooney is going to end up with 16,500 votes. And that's the way you're going to do 7 and 8, but you've got to use the statistics for Jones in number 7 and the statistics for Alvarez in number 8. Okay. Then number 9 says, suppose 1/2 of the undecided voters vote for Jones and the other half vote for Alvarez. Predict who's going to win there. Well, you can actually solve number 9 without even doing the math. Look at percentage who voted for Alvarez and the percentage who voted for Jones. That's a pretty big hint there. Okay, backside. Are you going to do stuff like 10, 11, and 12? 10, 11, and 12, I think you should think about using the formula percent of change equals the amount of change over the top of the original amount. And keep in mind that when I say this formula over here, I really mean x over 100. Percent of change equals the amount of change over the original amount. So let's do something similar to number 10. Number 10 says we're going from 50 all the way up to 200. I'm not going to do that. I'm going to do 50 all the way up to 300. Similar problem, just not exactly the same. How much is the change here? The change is 250. How much is the original amount? The original amount was 50. We write x over 100 on this side, and we solve for x. In this case, x would end up being 500% increase. if I solve that problem. 250 times 100 divided by 50 is 500% increase. So a percent of change equals the amount of change over the original amount. Let's do one similar to number 11. Similar to 11. 11 says, let's take something that's $79 and turn it into something that's $63. I'm not going to do that. Let's take something that's $80 and turn it into something that's $50. So, how much is the change there? The change is $30. How much is the original amount? The original amount is 80. And then I put x over 100 and I solve for x, right? In this particular case, if I solve this, my x value would be 37.5%, and it's a decrease this time. The price went down. That's a decrease. So that's how you're doing on 10 through 12. Okay, 13 through 15. Boy, this is getting a little long. It's already 11 minutes. 13 through 15. How am I going to do those? Well, we're either talking about discounting the price of something or talking about putting a sales tax on something. So let's try something similar to 13. DVD player is $199 and they're discounting at 20%. I'm going to change that price from $199. I'm going to change it to $150, and let's see if we can figure out how to discount it 20%. What I would do is I would think about 20%. What is 20% of the 150? And that's really 0.2 times 150, or 0.20 times 150, and that's really the number 30. So that 30, we then have to take away from the 150, and so the discounted price in this case would be 150 minus the $30. The new price of the item in this case is 120. So that's similar to $13. That's similar to 13. How about 14, where you got a sales tax? How would I do that one? It's basically the same problem, just slightly different. They've got something that's $29.50, and they want to put on it a 5 1/4% tax. Okay, I'm going to do this problem, but I'm going to do it with, how about a 6 1/4% tax. So again, I'm going to think in terms of what is 6 1/4% of the 2950. And I'm going to change this to a decimal number, 6.25, and then I'm going to change it from a percent into a decimal number, so that's 0.0625 times the 2950. Grab my calculator, because I can't do that one in my head very quickly. And I get this number, 1.84375. Now, money is not 5 decimal places, so I'm going to change this to an amount of money equal to 184, but that's not the answer. Remember, that's the tax being added to the original price. So I guess still got to take this number, 184, and I've got to add it to this number. And when I do that, I'm going to end up with my final price. So my final price in this case is $31.34 once I added the tax to it. Okay, so that's problems 13 through 15. How about 16 through 18, where they're talking interest, principal, rate, and time? I'm going to do something similar to number 17. 17 has a principal of $725. It has an interest rate of 4%, and it has a time value of 18 months. Now, the typical formula for this is interest equals principal times rate times time. And the time is supposed to be in years. The time is supposed to be in years. How do you handle it when you got months? Do you remember? Well, again, I'm going to change this slightly. What if it's $800 at 4% for 18 months? How would I handle this? Well, I'd take 800 times the decimal version of this, which is 0.04, and I'd multiply that by 18/12. I'm changing months into the years by saying 18/12 of a year. 18/12 of a year. If you divide 18 by 12 on your calculator, you're going to get 1.5 years or 1.5 years. So now I've changed the months into years, and now I can solve the problem. What do I get? I don't know. 10% of 80 would be 80. So it's what, 40 times 1 point. Oh, that's 60. This is the number 60. So in this case, the interest is $60. I'm pretty sure. Let me double check. No, it's not $60. Wait a minute. Pose of the clown times 0.04 times 1.5. Nope, sorry, it's $48. My apologies. $48. Okay? So that's the answer to that one. That's how you're going to do 16, 17, and 18. If it's not in months, if it's in years, you just leave it as years and solve the problem. I think that's where I'll stop this. Thank you, sixth graders. Talk to me if you have any questions.